On Monday, I'm going to hand you a piece of paper that looks just like what you did last night, but it's going to be 15 questions. Okay? It'll look like this. Okay? Actually, no, I've got them switched. It'll look like this. So it'll be 15 questions. Okay? Not because I like torturing you, even though that's kind of fun. I like you understanding the stuff, and it takes practice. It just takes practice. Okay? So doing the practice is never fun. Okay? Practice for a sport is normally not fun if you're actually doing it the way that's going to make you better. Okay? Practice for this is not going to be fun. It's going to be difficult. But it's making you better at it so that while you might not be a math teacher and think that this is fun, it might be easier. Okay? So we got to practice some of this. So what we're going to do is I'm going to scroll to each individual slide. I guess I need to clear these. I need to scroll through each slide, and you're going to try and work it out. And then I'm going to work it out. And then you're going to work it out. And then I'm going to try and work it out. Okay? We're just going to go back and forth. That's what we're going to do today. You do not have homework today. I have the thing I'm going to hand you on Monday printed out. If you would like that early so that you can try that on your own, then I can give that to you early. Because right now I'm going to hand it to you on Monday. You're going to work during class on Monday, and it'll be due Wednesday. So if you want extra time to do that, I can give it to you early. I have it printed. Okay? All right. So we want to scroll to the first one. I want you to scroll to the first one, and I want you to try and just work out the first one. Okay? Scroll to the first one and try and work out the first one real quick while I get this ready to go.
The first one doesn't even say equal.
Right, the first one is just simplifying. Okay? Like the end of section 1.
Anyway.
Also, today is one of those days where if you come up at the end of class, I will send you these notes completed. These notes are very organized, so much so in the way that every step is highlighted so you know exactly what I was thinking at that point in time. Okay? So I will send that to you if you would like it. Okay, so the first one is just asking you to simplify. Okay? So how can we simplify this thing? There's no algebra to do. So what we do is we change everything to sines and cosines. So tangent turns to sine over cosine. And cosecant turns to 1 over sine. In algebra, if something's the same on the top and the bottom, they cancel out. So that's 1 over cosine, but we don't like fractions, so we can change 1 over cosine back into secant theta.
Hey, are we turning in our homework?
Oh.
Oh.
Yep.
The more you know.
Because I did tell you that your test questions will come directly off of those, so I don't want to take them from you, so that you can look at them later. Okay? All right, so that's what we're doing. Again, that I did without looking at my sheet at all. I'm not telling you need to memorize the sheet, but that would help to be able to do that without the sheet. We should know reciprocals pretty well. Okay, looking at the next one. We're going to follow those steps. So these steps right here. Is there something resembling sine plus 1 or sine minus 1? Multiply by the conjugate. Is there a trig function squared plus another function or plus a 1? That's something we look at our Pythagorean identities for. We always compare to the other side, and then at the very end we change the sines and cosines. I'm going to add a step 0. Step 0 is algebra. Algebra, so that means FOIL, distribute, factor, okay, stuff like that. It might not always come at step 0, but that's one of the things we want to look for. So like this one, step 0 is algebra, right? So what would you maybe do first? Yeah, distribute. So that'll get you to the right answer, but we actually want to look at Pythagorean identities first if possible. And I know I put that later on the list, because normally they don't show up till later, but there's a Pythagorean identity right there. Yeah, is that what you're saying?
I was gonna say that, yeah.
Yeah. So inside this parenthesis, what does 1 plus cotangent turn into?
Cosecant.
Okay, so that turns into cosecant squared, and then this is sine squared. Two ways that you can view this. Okay, one way that you can view this is that those are reciprocals. So when you have reciprocals multiplied by each other, they equal 1. The other way that you can view this is you can have one more step and change everything to sines and cosines. So that'd be sine squared multiplied by 1 over sine squared. And then you can change that to a 1 because the signs cancel. Okay, let's try the next one. Okay, so this one this is the one I worked out for you guys at the end of class. Which side is harder? I think subtracting is harder, because when we're subtracting fractions, which is what cosecant is, then we need to find common denominators. So we're going to do the left side first. Okay? There's not really algebra to be done. There's no distributing, no foiling, no nothing like that. So we're just going to switch everything to sines and cosines. So sine x minus 1 over sine x. We can't add a number to a fraction. So because we can't add a number to a fraction, we need to multiply by sine over sine to get a common denominator. So that is now sine squared over sine minus 1 over sine. So that's sine squared minus 1, which should be a red flag. It should tell you what we're doing next. So on the top, that should be that thing that you recognize. We should look immediately to our Pythagorean identities and tell me that that is what? Let's think about it a little bit. What is our Pythagorean identity? Our Pythagorean identity is sine squared plus cosine squared equals 1. So this says sine minus 1. So it's going to end up being a negative cosine because we want sine minus 1. So we'd have to subtract 1 from both sides, and then we would have to subtract cosine from both sides. Everybody see how that becomes a negative cosine? Okay? That manipulation happens a little bit. Over here, that'll cancel. Over here, that will cancel. So that's why it ends up being a negative cosine. Be careful of that. But you know that it's going to have to end up being negative. That's why proofs are a little easier, because you know what it has to be. Okay? So that's going to end up being a cosine squared with a negative on the top and a sine on the bottom. Okay? We always want to look at our opposite side. We always want to keep comparing. So we've got some stuff correct. We've got a negative cosine, but we have 2 cosines. We just want 1. So what I'm going to do is I'm going to break up the top and write it twice. So cosine, cosine over sine. And again, the reason I broke that up is because right here I have a negative cosine, and right here I have a negative cosine. I don't want the squared. Okay, whatever's left over, hopefully turns into whatever's left over. So that cosine over sine will turn into that cotangent, because of our identities on our sheet. So that'll end up being negative cosine cotangent. I guess I need to write it twice. Negative cosine cotangent. This is one of those lessons that normally makes sense while I'm saying it. Does it make sense right now while I'm saying it, at least? Okay? It just takes a little bit for you to recognize it in order to say it. Yeah?
Could you also, on that one, instead of taking that negative cosine times cosine over sine, instead of turning that into negative cosine cotangent, could you just bring the right side down and work on that and bring it to negative cosine cosine?
Yes.
Okay.
Yeah, so you can always manipulate both sides. It's just I try to stay at one side just so your mind is working on the same linear progression. Okay? But yes, if you get stuck here, then go deal with this side. See if you can change it. Okay? If you wrote down cosine, which a lot of people do on this problem, then you get to the end and you'd say, well, why is mine positive and theirs negative? So then there's somewhere up there that you can maybe figure out why that is. Okay? All right, so this is very similar. I'm probably gonna make this into a proof. Yes, it equals 1. Okay, so equals 1. Obviously, the left side seems harder. So you need to find a common denominator if you're gonna add those. But there might be something that makes this easier that maybe you recognize. Yeah?
Don't you just, if you were to just secant, turn the secant and cosecant into like cosine and sine, it would just be cosine 2 plus sine 2 equals 1.
Exactly right.
It'd be 1 equals 1.
So you could make this harder on yourself. Okay? You can make this harder on yourself and get a common denominator, and you would end up getting to the right answer. However, if you notice that this and this are reciprocals of each other, again, if you have that memorized, you'll recognize it better. This would turn into 1 over cosine. So if you multiply by the reciprocal, it's going to be cosine squared, flipped, sine squared equals 1. That's our Pythagorean identity. There's your proof. So I'll write it down so you can see it. But that's going to be cosine. I'm going to make that an x instead of that a. 1 over cosine plus sine x over 1 over sine x. Dividing by the fraction is the same as multiplying by the reciprocal. So if I multiply this by cosine over 1, that's cosine squared x plus sine squared x equals 1, so 1 equals 1. There's my proof. Okay, so again, you could find common denominators. It would work if you found common denominators. But then you're dealing with four different functions. You're dealing with cosine, secant, sine, and cosecant. And so it would just, me personally, it would be overwhelming. So that's one of those ones where you might just recognize that if you have the reciprocals in your head a bunch. Okay? Okay, here's one of the ones that was off the homework. A little bit harder. Anybody have any idea what we do to start this one? Do you remember? Yeah? Say that again?
It's like 2 cosine something, and then like minus 2 sine. I don't know how to get there, but.
You bet you remember it?
Yeah.
Okay, so this is our algebra step, our step 0. This is difference of squares. Okay? This is something squared. It is cosine squared squared. This is also something squared. It is sine squared squared. So this goes all the way back to a plus b, a minus b, right? If you've got x squared minus 25, that turns into x plus 5, x minus 5. So we can do cosine squared plus, cosine squared plus sine squared, cosine squared minus sine squared. Plus sine squared, which should look familiar to you. Cosine squared minus sine squared. Okay? This should look familiar to you because it equals a 1. So we actually can just get rid of that because we're multiplying by a 1. So there's no reason to even have it there. Okay? So that means this is all we have left. Cosine squared minus sine squared. Okay, there's no more algebra to do. the cosines and sines are already cosines and sines. So we just have to look where we're going. Where are we going? We're going to only sines. So I have to get rid of this cosine. So cosine squared, what is cosine squared? The same thing as?
1 minus sine.
Yes, so I can take this part right here and I can turn it into 1 minus sine squared minus sine squared. Okay, so that actually got rid of our cosines. Now we have 2 sines, which is what we want right here. We have 1 negative sine and 1 negative sine. So now I have 2 negative sines. And then I can put plus 1 here, I can put plus 1 here. So there's my proof. Okay, that one has potential to end up on the test. So is there something that needs to be explained there? Everybody see how it becomes difference of squares here. Okay, the main goal is continue to look at this side. I would have gotten stuck here if I hadn't looked here and said, oh, I need to get rid of my cosines. And we know how to get rid of our cosines because we've got something to replace it with. Okay, we're going to follow a similar path on this one. I'm going to give you a couple seconds to try. Okay, so something immediately should be recognizable to be replaced, and then you need to look at your other side and see that you only want sines. So we need to get rid of our cosines. But there should be something immediate that should make you look at your Pythagorean identities. See if we can get there.
Right? Maybe? Possibly?
What?
This is,
No, but look, this is a Pythagorean unit.
yeah.
So it comes straight into sine squared.
Oh.
Okay, so that first one's going to turn into a sine squared. The second one's not going to turn into anything. So you're just going to write it down again. But then you have to get rid of your cosine just like we did on the last problem. How do we get rid of cosine squares? We change it into 1 minus sine squared. Yes.
I don't know what we're talking about. These are that changed to 1, and that's it.
Why did that turn in?
Because this says, oh, it's really, never mind. Never mind. Leave it there.
Jack, did you get there?
Mm-hmm.
Sweet. Anybody else there? Got it? Raise your hand if you want me to start. Okay, I'll start. Okay, so remember the first thing you want to recognize is Pythagorean identities. That right there will immediately turn into a sine squared. That is something that should be in your head by now. It is something that we have talked about a bunch. So that's something that should be there, and then this 1 plus cosine looks kind of like a Pythagorean identity, but there is no way for us to manipulate that in order to be 1 plus a cosine. There's no way for those to be on the same side of the equation with the same sign. Okay, so the next thing we do is you might want to distribute. That's an option, because we do algebra a lot of times when we see algebra to be done. So you could distribute. I'm going to wait to distribute right now because I've got that cosine squared and I don't like that cosine squared. If we look over here, there are no cosine squareds. On the previous question we just talked about, I can replace cosine squared. So sine squared theta, 1 plus, and I'm going to replace cosine squared with something else. If you look at your Pythagorean identities, I don't think I have that sheet. If you look at your Pythagorean identities, what can cosine squared become? 1 minus sine squared, and I'm going to put theta. Okay? So again, this, we did not want that. We wanted sines, so I changed it to this, using what we know. Okay? Now it's just combining like terms, and there is our algebra step as well. We're going to distribute. But first, let's combine our ones. So sine squared theta, 2, because we combine our like terms, minus sine squared theta equals, and now we do this algebra step where we distribute it, and it's going to be 2 sine squared theta minus sine to the 4th, because when we multiply we add our exponents. And there's my answer. Okay, I've never worked that out where I distributed the sine squared. It will end up working. It just might be a little bit more difficult. But it will end up working itself out as well. Let's skip that one and go straight to this one. Okay, what's our step number 1? Because step number 0 is algebra. Our step number 1 is multiply by the conjugate if you see something that needs to be multiplied by the conjugate. So on the left side, because that's the one I'm going to do, because it doesn't really matter, but on the left side I dislike cosecants more. I like sines more, so I think that's easier. So over on the left side, I'm going to multiply it by 1 plus cosecant theta and 1 plus cosecant theta. Remember, that is because we saw something that resembled a 1 plus or 1 minus something. Okay, on the top we need to FOIL that. So first times first is 1, outside times outside is cosecant. Inside times inside is also cosecant. If you know the shortcuts on these, it is a very nice thing. And then cosecant squared theta. Okay, I'm going to go ahead and erase and combine like terms in the middle. So I have 2 cosecants. I'm going to change that to 2 cosecants. So I just combined my like terms in the middle. On the bottom of this, the reason we multiply by our conjugate is because it turns into a Pythagorean identity. 1 minus cosecant squared theta. If you FOIL, you'll get that as well. Anybody know what the bottom turns into?
Cotangent.
Look closer. Negative cotangent. Look closer at how you can manipulate that. The bottom of this will become a negative cotangent. So 1 plus 2 cosecant plus cosecant squared theta over a negative cotangent squared. Okay, at this point, you can break up your cotangent underneath each piece. And and then have fractions on top of fractions, and that looks really difficult. So I'm gonna go over to the other side and hopefully try and change the other side to make it easier as well. Okay, so you can continue from there. I do continue from there normally, but I'm gonna see if there's an easier way on the right side. So what do I need to multiply the right side of this by?
Sine plus 1.
Yes, sine plus 1, because it's the conjugate of the bottom of this. Sine theta plus 1, sine theta plus 1. Again, we've got those shortcuts, so I'm going to use the shortcut this time. Square the first, multiply them together and double it, so that is 2 of the sines. And square the last, so just a 1. On the bottom, I get sine squared theta minus 1. So what does the bottom of that turn into? Is it negative cosine? Is that what it is? Yep, yep, negative cosine. Okay, so the bottom of that turns into a negative cosine. Sine plus 2 sine theta plus 1 over negative cosine. Okay, so those didn't end up being each other, so we do have to go further than this. I'm going to go further on the left side because I want to change to sines and cosines. This side is already sines and cosines. Okay, so I'm going to keep going on the left side and change stuff to sines and cosines. Okay, so that's 1 plus 2, 1 over sine, plus 1 over sine squared, all over negative cosine squared over sine squared. One more time, if you're looking back at your sheet every time for that, that's going to be a little bit harder. So if you've got those in your head, it's going to go a little quicker for you. Okay, so what can we do here? Well, we got a bunch of fractions. We can multiply by sine squared to get rid of those fractions. I'm going to do that. That's what I would do. It's not what my notes do. But if you've got fractions, you can multiply by the common denominator to get rid of those fractions. So what if I multiplied every part of this by a sine squared? Okay? So if I multiply a sine squared by that 1, that becomes a sine squared. If I multiply a sine squared times this, one of the sine squareds is going to cancel, and what's left over is a 2 sine. And then if I multiply this times a sine squared, my sine squareds both are going to cancel, and that's just going to be a plus 1. On the bottom of this, well, that worked out a lot better than what I used to do. On the bottom of this, if I multiply the sine squared times the bottom of this will cancel, and on the bottom I get a negative cosine squared theta, which is the exact same thing as it is over here. That one actually wasn't that many steps. That was just foiling about 4 times. We're a very lively bunch today, guys.
Well, you just know us in our math.
I just know you. Okay. I want you to try this. Look at the bottom. They look like something you should multiply by the conjugates. So again, you're going to FOIL twice, but then you're just going to start combining like terms. It'll work itself out. But you need to do conjugates first. Okay? Multiply the first one by the conjugate of the bottom. Multiply the second one by the conjugate of the bottom. This one actually looks very, very
If you said easy.
easy. It's just, this, you know how to FOIL, right?
Yeah, but
So
I've
just
given up
FOIL.
at this point.
Just FOIL.
Foil what?
FOIL each one by its conjugate. Multiply the first one by a 1 plus sign. Multiply the second fraction by a 1 minus sign. FOIL top and bottom. I know it's crazy because it's got signs in it, but it's just foiling. And you, all of you in here know how to FOIL. All of you do. You do. It's just a lot, but you know how to do it. Just, it's a heavy problem. It is not an impossible. It's just FOIL.
It's useless. Yeah, I'm with her on that.
I actually really like that last one, now that I realize you can multiply.
That last one was awesome.
Yeah, so awesome.
It's just the greatest.
Like, I wish I could
I'm so
marry
happy to
it.
be sitting in this seat.
Well, the last one, see, I used to do it a different, that's not what I wanted. I used to do it a different way.
You wanna pull up the answers?
See, here's that last one. I used to do it a different way. I didn't multiply to get rid of my fractions. I just started breaking stuff down way too much.
That's so gross.
I know. So if you realize that you can multiply to get rid of your fractions, it's so much easier.
What if the top signs just cancel out, or am I dumb?
The O and the I of your FOIL, yes.
No, like, see, so this one right there, and then
One
this one
times
goes
one,
there.
one times one. FOIL, so 1 times 1. Then outside,
Oh, okay.
inside. And remember on the bottom, because it's conjugates, that's gonna be the FLA, the FL of FOILing. Then remember to distribute that negative sign. Cause then you'll have stuff cancel out for you.
Am I doing good, Mr. Mason?
Hmm?
Am I doing good?
Awesome. And then you have to multiply this one by its conjugate as well.
Oh, boy.
And that should be sin squared.
Oh.
Yeah.
So those two would cancel out, right? Because it's
Did you distribute negative?
Yeah.
But I don't think we want it to cancel out, right? Because we have a floor one, so those two combined would be 4.
No, because those, that's a plus two sign, like a negative two sign.
Is it supposed to be?
I don't think so, because.
But it's negative, right? If you use negative, that would make it a plus.
That would make it a plus.
And that's why I say always look at the other side, right?
That was one of those situations where the plus sign messed me up.
Yeah.
Where I was like, oh, plus sign, cool. No.
I don't know, man.
I don't understand how that was helpful.
Get it?
I don't know.
You know, sometimes
Well,
you won't ever see why people are helpful.
it's okay, I give up.
I would, if I were.
Did you only do one of the fractions though?
Could be.
You have to subtract them.
What do you mean?
You're subtracting 2 different fractions.
Now what? Was I right?
You're gonna be
How about I just multiplied
now
it by
you're subtracting 2
-1
and distribute that negative
yeah.
sign for everything on the top of
On
this.
one side I did apparently.
And then you just put them all over one big fraction with a cosine.
And that would make sense if I decided to just add a random two in there because that's what it is. Cosine squared.
Because this turns into a cosine squared.
Oh, yeah.
So 1 plus 2 is another 1.
Okay. The things that happen in my brain are hard to.
What time is this class?
Now.
4 minutes?
Can you just work the problem out?
Okay, I'm working it out.
Thank you.
I'm gonna do a decent amount in my head though. Okay, so we should recognize, we're gonna run out of time, listen. We should recognize that these need conjugates because they're not squared, but they look like they should be. Okay, this looks like a Pythagorean identity, so if we take our conjugates and multiply them, 1 sine and 1 plus sine, we also have to do this one though. So 1 minus, that's weird, 1 minus sine and 1 minus sine. If you know your shortcuts, this top of it is first thing squared, multiply and double the two things, last thing squared, which is sine squared. On the bottom, the reason we do conjugates is because it turns it into squared. So 1 minus sine squared. Minus, over here, square the first. Multiply them together and double it. Becomes a negative 2 sine. Square the last, which becomes a positive sine squared. That's just foiling. We should be able to do that. Okay? Minus, or 1 minus sine squared. We are subtracting a fraction, so we're going to take this and distribute it. So minus, plus, minus. This is all the same denominator, so we can put it over one big fraction and put it all over 1 minus sine squared. Okay? So now that's all over one, let me erase this, it looks weird. Okay? That is all over 1 minus sine squared, which becomes cosine squared on the bottom. If cosine squared is on the bottom, what's on the top? Well, on the top we have a 1 and we have a negative 1. We have a sine squared and a negative sine squared. So what we have left is 4 of these sines. 4 sines. Continuing to look at the other side, that 4 looks good to me. The rest of this needs to be dealt with. Well, I know that tangent is sine over cosine, but I have 2 cosines. So I'm going to take that cosine squared and I'm going to split it up into 2 cosines. Sine over cosine turns into a tangent, so 4 tangent. Cosine on the bottom, move back to the top, turns into a secant. And there's my answer. Okay?
Wait, hold on. Wait, how did you get the tangent?
So I split up the cosine into 2 cosines rather than cosine squared. So this becomes tangent, and this becomes secant.
We really just gotta start writing and hope for the best.
Okay. And again, if you know those little things like the reciprocal identity and the cotangent and tangent identities, then you'll start recognizing that ending result. The hardest part about that was foiling, but we should all know how to foil. Okay? Yes?
I think I got it right, because in my head I knew to cancel out and combine, so I just did one of them. That way when I got to those tangents, they come together, so I am right.
I would have a hard time knowing that you proved it, though, because you only did one part of it.
We already have the answer, why do we need to prove that that's the answer?